All right, for problem number 13, it says a projectile fired over level ground has an initial velocity of 70.8 meters per second. It is in the air for 7.8 seconds. What is the x component of the velocities of the projectile's initial velocity? This is in your notes. So, first thing we do, draw a picture. So, here's my somewhat level ground. There, it's level up. Oops. There we go. And let's assume that this is a cannon or something. And inside the cannon is a ball. And that thing's going to get shot out of here at 70.8 meters per second. So that's the initial velocity. And that thing goes. The time it takes for it to hit right here, 7.8 seconds. What is the x component of the initial velocity? So we know there's a couple of things. So the x component, and so we have the initial velocity is equal to the square root of v sub x squared and the initial velocity in the y direction squared. Or you could think of it as v naught squared is equal to v sub x. And this is in your notes. That's why we write all this stuff down. When you go home and you go to do your homework, you're supposed to just look in your notes and try to find an equation that works. What do we need to know? We need to know v sub x, the initial x velocity. All right. There's a couple ways you can handle that. One is we could figure out, I know that it reaches a maximum height at 1/2 of that. So the max height occurs at whatever 1/2 of 7 point, what is that? 3.9? I think so. Let's just try it on the calculator and see. So if I say 7.8 divided by 2, yeah, 3.9. So this 1/2 of that is 3.9. So in order, the problem is, and also you could say that v sub x is equal to v initial times cosine of the angle theta. Unfortunately, we don't know the angle theta. So I either got to decide, I either got to figure out what v sub y is, which I can do, and then I'll plug it into this equation and figure out what v sub x is. Well, how do I find that v sub y? Easy, we just did it on the last problem. We say that the final velocity in the y direction is equal to the initial velocity in the y direction, right? Plus the acceleration times time. Well, we know that at the maximum height, v sub y, the final velocity is 0, right? So this becomes 0. We don't know what this is. That's what we're trying to solve. Plus the acceleration due to gravity is equal to 9.8 meters per second squared, right? So that's technically negative 9.8 times the time, which is 3.9. Okay. So let's do that on our calculator. If I say negative 9.8 times 3.9, it's a negative 38.2. So when I add that to both sides, I get 38.2 meters per second equals my initial y velocity. So if I want to find the relationship between these two, I'm just going to subtract Vy naught squared from both sides. And I get V squared minus Vy naught squared is equal to Vx0 squared. All right, so I'm going to plug those numbers in, right? That becomes, and I'll write over here at the top, we'll just go 70.8 squared minus 38.2 squared is equal to V sub x 0 squared. So we're going to use the calculator, and I'm going to say 70.8. Oh wait, I got to do the parentheses, don't I? So I got to do this 70.8 squared plus, no, not plus, minus. Okay, good. 38.2 squared. Close my parentheses. So it's about 35.53, and then I'll have to take the square root of that, right? Let's just write it down. 3553.4. Oops. So then I take the square root of both sides. And I get pretty close to 60. Meters per second.